Dave Linder is a software architect here at Maplesoft and a fellow math group member. He's going to show us some tools that can help us improve our Maple visualizations. So please go ahead, Dave.
Hi, everyone. Okay, so today I'm going to give you some examples, some of my favorite examples, things I find either that come up often for me or things I see asked questions from users. Sort of like a tips and techniques, but going from the easy to the slightly more advanced. I'll share my screen. Okay, can everyone read that? I assume so. Tell me if you need zoom more. So my first example is going to be on parametric plotting. So as you know, the plot command and the plot3d command have different kinds of calling sequence. And one of the calling sequences that they allow for is where the first argument, instead of being an expression, is a list. In the case of plot, it would be a list of two things followed by a range. Or in the case of plot3d, it would be three items, and then outside the list are the usual pair of ranges. But those ranges aren't the X and Y ranges anymore, they're the ranges for the parameters. And each of the elements inside the list can take on formulas using the two parameters. And in the case of the 2D plot, the first coordinate represents the X value as it gets computed on the fly from the parameters, and the second coordinate represents the Y value. And so you can make a variety of different kinds of plots. So my first example is a very simple one, which is you want to do a 2D plot, but you want to switch the roles of the X and Y axis. So suppose you want a plot of y squared equals x, with x axis being still the horizontal. So one way to do it, the difficult way, is to produce the normal plot and then simply transform it using Plot Tools transform, where we switch the x and the y. And so the axes get reversed, all the values get their pairs reversed, and you get the result we wanted. But the easier way is to use the parametric calling sequence. First of all, I'll just do a parametric calling sequence that's totally equivalent to y equals x squared. The first value is the x component, the second value is the y component. So what I'm going to do is I'm simply going to reverse those, where this is now the x component, or the horizontal component, and this is the vertical component. And so we see that with just one call with a parametric calling sequence, we can flip our axis. We could do all kinds of other transformations as well, but this really simple one can be done directly without any effort. Okay, going to move on now to some implicit plots. So I have an expression in x, y, and z. And the way to do a plot of where that surface or that hypersurface equals 0 is to use the implicit plot command, where the expression is the first argument. And even if I don't set it equal to 0, it assumes that it's an equation equal to 0. If it's an equation, then it works fine. But if it's just an expression, it assumes the equals 0. I'm going to make that plot. And it thinks for a while because it has to work quite hard to do all kinds of stuff. It works a huge mesh of points all over this area. And then it populates where the values are at each of them. And then it sort of interpolates where the 0 surface must be. The result is kind of clunky because in order to get a good surface, it has to use a lot of points. And then the mesh is so dense that the black takes over. So if I put stylistic surface on, then I get something that looks more like a nice colored surface. But we can still see artifacts, lines on the surface. It's kind of a bit clunky. It's the GUI doing its job of interpolating from a data which is just pure values plus or minus 0. And it works out where the surface has to be and then renders it. But this expression, we can't explicitly solve it easily for Z. If we could, sometimes you'll get like, something which isn't a mathematical function. So there might be like two solutions and you have to stitch them together. But what we can do is easily solve this for X. The X comes right out. We just bring it to the other side of the equation. If I solve that expression for X, then I get this expression. So X equals this. So what I'm going to do now is I'm going to do a parametric 3D plot. The X component of my plot, or the first horizontal component, is going to be this solution. This is x as a formula, or formula for x. My parameters are y and z, and they're the other two parameters. Now I get actually a much faster result, which is also much, much smoother. So the trick here is if you want to use implicit plot3d, and you have a formula that can be solved for any of the three variables standalone easily, either the x, the y, or the z, then solve it first up front. I believe that the code in implicit plot3d now does that for the z component. It tries to see if it can solve for z, but it doesn't yet, not in release 20, Maple 2024, it doesn't try and solve for x or y, see if it succeeds, and then use that. So, but we can do it by hand, as I just showed. I hope in the future we'll make that automatic. My next example is a density plot. Now, we have this beautiful option in plot3d and density plot and contour plot for using a color scheme. And we can use a range of colors, and we can say, I want the color or the shading to vary by Z height. So I say Z gradient. I could get it to also vary by Y or X gradient, but that wouldn't really look so interesting on a surface. What I wanted to do is change color as the height of the plot of the surface increases. By default, sorry, by default, it uses an RGB color space. I put it in here even though it's the default. And so we see that the colors go from red to green. But in RGB color space, those colors don't really vary very well, because the RGB color model and the color spaces within it aren't what good perceptual color spaces, in the sense that if you vary the values slightly, then the colors don't perceptually always change by the same amount. It's not a linear change in the perceptual difference. But Maple has other color spaces, some of which are perceptually changing. I'll take a quote from a wiki page: a change in the amount of color value should produce a change that is of the same visual importance. So there are a couple of color spaces that do that. The LUV and the LAB color space are like that. I'm going to try it again. Now I get quite a different surface. Here we see a much smoother perceptual visual gradient. The blending of colors is much smoother and kind of linear. We can see that there's really a nice, smooth and gradual change between the colors. So I haven't seen people use this in the field, but I really think it makes a difference. We have a whole bunch of different color spaces we can use, and you can use more than one color. You can go XYZ color space or LAB. There's a whole bunch. You can even do hue color space if you want the color wheel. But I think that this is a really great trick to getting a really nice, smooth shading of color. Depending on where the colors are in the color wheel, the difference can be quite significant. A lot of colors, if you choose like opposite complementary colors, it can go through that really nasty, muddy gray or brown, and you can sort of change the effects so that going from, say, blue to yellow would go through orange instead of a muddy gray. It's quite nice. Okay, my next example is plotting from data. So this is interesting because this example, I must have worked out the solution to it half a dozen times. And as I was working on it this past week, somebody else asked the same question again. In fact, I'm going to use their data. But I've seen the same kind of question over and over, which is basically you have data which your program writes out something like this. The first component stays the same while the second changes. Then the first component increments, and it runs through all the values in the second again. And it does that until all of the first component choices are done. So there's only 4 or 5 values for the first component and 7 values for the second. And then these are the corresponding Z heights. There's a very common way to produce your data like this, either using a loop or a sequence of sequences and so forth. So I see this kind of data a lot. The question is now, how can I plot a surface from it? What's the easiest way? Well, there's several different ways, but here's the one I chose. What I'm going to do is I'm going to reformulate this data as a 7 by 4 by 3 array. So it's a 3-layer array. The first layer is the X values, the second layer is the Y values, and the third layer is the Z values. So I'll just show you the 3 layers. So as we can see, there's repeats here in the X and Y, and then finally the Z. So I don't need to print this out, but I'm just doing it for us. So I'm going to take this R and I'm going to throw it right to the surf data command. And that plots the surface directly. Another interesting thing about this is that I said I had semi-regular data in the sense that these values aren't all regularly spaced between 80 and 100. But there is the same number for them for each line. So it's possible to have quite irregularly spacings of the X or the Y data. As long as they're sorted properly, we can still get the same effect. In fact, we can actually get a surface which has an irregular boundary. And that's very nice because that will work. This plotting mechanism with the GUI rendering it from the array, that will render a nice surface even when the boundary is irregular. It won't interpolate values that are higher than 0, for example, outside of the boundary if the boundary was, say, non-convex. So we don't have to rely on like interpolation methods that only work on a convex hull. Just for fun, I'm also going to make the interpolant from this. I'm going to use the same R, and I have the 2 vectors or lists that reappear each time. And I'm going to put them in as the data and then the Z layer. And this returns an interpolating function. This interpolating function can now be used wherever a black box for the original data might be used. For example, I can give it any arbitrary XY point and pass it to this function, and it will return the corresponding interpolated Z height. So I can simply call plot3d on it. And I'm going to do this, or I can call plot3d with style equals point. I'm just overlaying these two to show you that they do agree. Here we have the surf data in green as the surface, and here I have the point plot produced using the func function, the interpolant. Or I could simply use the interpolator to plot the surface itself. And if I had many points and it was a wavy curve, I would get far better granularity than I would in the original. Okay.
Okay.
Are there any questions?
Heads up that we're just running up on time.
Sure. I have only one last example,
Okay.
which is for fun. This is an advanced example. And I should mention that the worksheets that we're using in these demos today are all going to be available later on. So you don't have to like take notes or make copies or anything. You'll be able to access them later. What I'm going to do is I'm going to use embedded components to embed a mini worksheet in which I have a plot component with a fill color. And I'm going to use a fill color so that, and a plot component so that I don't get any little artifacts. The whole thing has a background color, but it's for a 3D plot, which you can't really do with regular plots. So this is my regular plot, as you can see on a white background, kind of the usual thing, but I'm looking for something a little more fun. And here it is. I can actually make this any background color I want. I could make it a light brown or whatever. And I've chosen obviously a light color for the axes and the grid marks so that we can still see them. But otherwise, it acts just like a regular plot. But I've never seen anyone sort of do this in practice, but I think it looks kind of sharp, especially if you do an array of arrays, like a grid plot or an array plot of this. You can get a really nice effect. Anyway, that's the advanced example. I hope that some of this will be useful to people. If there's any questions, this is the time to ask.
All right. So maybe quickly, we just have a question from Jean Paulo asking about maps and maps color. And that's all the context we have.
That's the question?
Yes, maps.
Maps like geographical maps?
Maybe Jean-Paul can explain and we can answer in the chat.